Hello, friends. We are going to discuss today Bicyclo compounds nomenclature. In this video, you will learn about naming system of bicyclo compounds and also substituted naming of bicyclo compounds. At the end of this video, I will also differentiate between bicyclo, spiro, and normal cyclic compound. So in the last part of this video, you will get the difference between what is spiro, what is bicyclo, and what is only simple cyclic compounds, right? So let's start with the naming rules of the bicyclic alkane, right? So according to the IUPAC name, bicyclic alkanes must have a format for their nomenclature. In the another video, we learned about spiro nomenclature. In that, the first word in the naming was spiro. But always keep in mind, when you have a compound which possess bicyclic system, then you must have to use a first word in the name is bicyclo. That is bicyclo, right? So bicyclo compound is a compound where the two carbon rings are fused with each other by two carbon. So let's take an example. Here you can see this is a ring. Here there is another ring. If you see, both are joined with two carbon. So that is called bicyclo compound. When two rings are connected with two carbon, that is bicyclo carbon compound, right? So first we have to write that is bicyclo. Then we have to make a big bracket. Into that we have to put two dots. One dot over here, another dot over here. And we should write some alphabet here, ABC. That denotes the numbering. That denotes the numbering, how much carbons are there, right? And at last, you have to calculate the total number of carbon present in the molecule. And according to that, you have to write the parent name of alkane. So this is the basic understanding how we can give the nomenclature to bicyclic. Let's see by rules. First rule, count the total number of carbon across the entire molecule. This tells you the alkane parent name that goes at the end. Means, suppose you have total 10 carbon, that should be decane over here. In place of parent name, you have to write decane over here, right? So first rule tell about the number of carbon present in the total entire molecule. See, one thing you have to keep in mind, when molecule is substituted compound, then you don't have to calculate the substitution carbon in your counting of the total number of carbon of bicyclic system. Otherwise, the answer will be wrong. Let's see by the example in the next slides, right? But you have to keep in mind, you have to calculate the total number of carbon present across the bicyclic system, not as a substituent, right? So let's see. Second rule, count the total number of carbon to the left and to the right, right? So whatever ring you have, say for example, we have a ring. One second. Right? So at the left side, we have 1, 2, and 3. Total 3 carbon, excluding the carbon which are fusing the ring. We should not calculate this both in the calculation of carbon for the numbering ABC, right? And we should see here 1 and 2. So at the left side, we have 3 carbon. At the right side, we have the 2 carbon. We not calculated the carbon which are fusing the rings, right? So one digit will be 3, another will be 2. Now we have to see in between these two carbon which are fusing the ring, there is no carbon. There is no carbon. So this denotes 0. This denotes 0. So here C equal to 0. Why? Because the two carbon which are fusing the ring, in between there is no carbon. So C is the number of carbon which is present in the middle of two fusing carbon, right? So C is here 0. Now A and B, one will be A, one will be B, which we should give A, the highest number of carbon. In the structure which we drawn, 3 carbons are there, so A should be 3 and B should be 2. Means we have to follow the highest to lowest order. Highest to lowest order, right? So this is the way how we will put the number in our IUPAC name. Where? Here, right? And the first word should be Bicyclo. So now final name we can write first word Bicyclo, then number of highest carbon either in left or right side, then the less number carbon, and then if any middle carbon is there between the two center, that should be C. If no carbon is there, then it should be 0. And at last, the total number of carbon present in our Bicyclo ring system, right? So this is the way how we can give the name to the Bicyclo compound. Let's learn by example. We will also learn simple bicyclic and we will also learn about the substituted bicyclic compounds also, right? So let's see the first example. You can see a molecule is in your screen, right? So here what we can see the 1, 2, 3 and 4. Total number of carbon present in this structure is 4. That is 4. It must name, the parent name must be butane. Why? Because 4 carbon means butane, right? Now let's see here from the fused carbon, the end of left side shows only 1 carbon. Here no other carbon, only 1 carbon is there, right? Here also 1 carbon, right? So both sides same. So A and B both will be 1, but C will be 0. Why? Because there is no carbon between these two fused carbon. So that should be 0. That should be 0. So in bracket what we should write? That is 110. Here what we should write? Bicyclo word. And here what we should write? That is butane. That is butane. So what the name become? That is Bicyclo 110 butane. I hope it is very clear, right? So that is the way how we can give the name. Let's see the next example. I am giving you 2 to 3 seconds. You please try. Take your pen and notebook and try to give the nomenclature, right? Let's calculate the number of carbon. 1, 2, 3, 4, 5 and 6. It shows the total number of carbon 6. So the parent name must be hexane, right? Parent name must be hexane. In between here, this 2 carbon don't possess any middle carbon. So C equal to 0. Both side 2 carbon in left and right side. So 2 is there. And Bicyclo we should write first. So the total name become Bicyclo 220 hexane. Bicyclo 220 hexane. So it's easy for you now. You can give the name to this structure also. Just giving you 2 seconds. Try. Calculate the total number of carbon. That should be 7. Right? If you calculate one side, that is 3 carbon. If you calculate the left side, that is 2 carbon. So higher number is 3. So in big bracket, we have to write first 3, then 2. In middle, there is no carbon between the center. That means 0. So Bicyclo 320 heptane, right? So we can give name in this way. Next one, the ring possess total number of carbon 5 plus 3 equal to 8. 5 plus 3 equal to 8. How we are calculating? 1, 2, 3, 4, 5, 6, 7 over here and 8 over here, right? So this is the way how we are calculating. Now let's see, the center is here, another center is here. In between there is no carbon. In between there is no carbon. So C is equal to 0. C equal to 0. In the left side 3, in the right side also 3 carbon, right? 1, 2 and 3. Both side 3, 3. It shows what? It shows as a name, that is Bicyclo 330 octane. Why octane? Because 8 carbons, right? Let's see the next example. Try to solve this. Total number of carbon, if you calculate, 1 ring 6 and plus 3, 9. So the last name will be no name. If you see one side 4, one side 3, higher digit is 4. So A should be 4 and lower digit should be 3, right? So B equal to 3, and previously we have to write Bicyclo. So this is the way how we can give them name of this compound. Now yes, you can see in this structure, we have total number of 1, 2, 3, 4, 5, 6, and the 7th here. So total number of 7 carbon. So last name, parent name must be heptane. Now there is a bridged carbon here. So C equal to 1. C equal to 1. Why? Because these are the two center. In between one carbon is present. So here C equal to 1. Both side 2, 2 means 2, 2. And first we have to write Bicyclo. But we have to realize the same structure can be drawn in this way. Both are equal. If you give the naming to this both compound, it will be same. Why? Because they are the same molecule, and same structure can be drawn in this way also. Same structure can be drawn in this way also. These three are similar. If you prepare the name, that will be Bicyclo 2,2,1 heptane, right? As I said, both side 2, 2. So A and B 2, 2. In between 1. That is C equal to 1. First Bicyclo, and total number of carbon 7. So name is heptane. Now let's see one example with substitution. So you always have to keep in mind, when you are giving the numbering, you should always start with a carbon which is a center, So one should be start from here. So the substituent methyl is present, the substituent methyl is present on carbon number 1. So 1 methyl, rest name how to give that you know. Bicyclo 2,2,1 heptane, as we are writing routine. But the first carbon should be a center. First carbon must be a center. You have total 2 center, right? You have to choose which one give you the less numbering to your substituent. Less numbering to your substituent, right? So that is the way how you can give the name to the substituted compound. Now let's see another example. Yes, you can see here substitution is not on the fused ring system carbon. That is not on the center, but nearby position. So you have to give numbering such a way which should make the numbering less. So start from here 1, it will be 2. So that will be the correct nomenclature. Why? Because substitution is getting number 2. If you start from here, then substitution will get 3. How? 1, 2 and 3. So that will be the wrong nomenclature. That will be the wrong nomenclature. So you have to give numbering in such a way, substituent must possess the less numbering. It means the name should be 2-methyl. Bicyclo, why you know? 2, one side 2, another side 2, that is 2, 2. In between 1 here, right? Bridged carbon is there, making 2 centers adjoint, that is 1, C equal to 1. Total number of carbon is 7. Always keep in mind, as I told you earlier, the methyl carbon, which is substituent, should not be calculated here. Right? It is a substitution. It is not a part of the Bicyclo system. So that is not calculated here. If you calculate this one, then the total will be 8, but you don't have to calculate in the main nomenclature, right? I hope it is clear to everyone right now. Now let's see the next example. Yeah, you can see here spiro system is there. So not spiro, sorry, bicyclo system is there. So that is bicyclo, one side 3 carbon, that is 3, one side 2 carbon, here 2, in between no carbon, that is 0. Here substituent is present, right? So if you start from here, that will be 1 and 2, 3, 4 and 5. Now one thing I should mention here, according to the rules, the numbering must be followed by the bigger ring. In Spiro, we were learning that we are following the numbering from smaller ring. But in Bicyclo, we should start the numbering from center and go to the bigger ring. In such a way, substituent must get lower numbering, right? So if you go here, that will be 6 and that will be 7, right? So this is the way how you can give the numbering. Even though the substituent present on smaller ring, you don't have to give 1, 2 here. That is 1 and 2 you don't have to give here. You have to go for the bigger ring first and then you go for the smaller ring, right? I hope you get my point. Let's see by example. You can see a substituent is here. We should not give numbering 1, 2 in this way. 1 and 2. We should not give numbering in this way, but we should go in such a way. The name should be 1, 2, 3, 4, 5, and 6. If you start from here now, in place of 5, if you write 1, then this will become 7. So that is higher number. So that is wrong. But this is the correct way how you can give the numbering, right? So I hope you get the exact idea about the nomenclature system. Now let's see which are called bicyclo, which are called spiro, and which are called normal cyclic compound, right? So if you have 2 ring system joined by only single carbon, that is called a spiro system. 2 rings fused with a single carbon. Let's take another example. So there is a carbon, single carbon which are joining these 2 rings. That is called spiro compound. But if you have 2 ring, joined with each other by 2 carbon, that is called bicyclo system. That is called bicyclo, right? Spiro is which one? 2 rings connected with single carbon. That is spiro. That is spiro. If 2 carbon ring joined with a single bond, that is called simple cyclic alkane. Simple cyclic alkane. No spiro, no bicyclo. Bicyclo, 2 fused ring, non-aromatic ring by 2 carbon, that is bicyclo, joined by 1 carbon is spiro, and that is simple cyclic alkane. I hope you get the exact idea about everything, right? Let's subscribe to my channel. If you didn't subscribe previously, don't forget to like this video if you like the content, and please share to your contacts which are relevant to the subject. Thank you very much for listening me patiently. I hope you will watch the more videos. After subscribing, press the bell icon to get the next updates. Thank you very much.